In deep learning, you should always aim to start your neural network training with a pre-trained model, and fine-tune it. You really don't want to be starting with random weights, because it means that you're starting with a model that doesn't know how to do anything at all. With pre-training, you can use 1,000 times less data than starting from scratch. However, sometimes a pre-trained model that is appropriate for your case doesn't exist. So we would like something which works better, or at least has similar results, but doesn't need the huge amount of annotated data pre-trained models use. The secret for this purpose is self-supervised learning. This is where we train a model using labels that are naturally part of the input data, rather than requiring separate external labels. Self-supervised learning is a relatively recent learning technique where the training data is autonomously, or automatically, labeled. It is still supervised learning, but the data sets do not need to be manually labeled by a human, but they can, for example, be labeled by finding and exploiting the relations, or correlations, between different input signals, that is, input coming from different sensor modalities. A natural advantage and consequence of self-supervised learning is that it can more easily be performed in an online fashion, given that data can be gathered and labeled without human intervention, where models can be updated or trained completely from scratch. Therefore, self-supervised learning should also be well suited for changing environments, data and, in general, situations. As Yann LeCun puts it, one of the godfathers of AI, reinforcement learning is like the cherry on a cake. Supervised learning is the icing and self-supervised learning is the cake. As he says, in self-supervised learning, the system learns to predict part of its input from other parts of its input. Self-supervised learning is supervised learning because its goal is to learn a function from pairs of inputs and labeled outputs. Like supervised learning, self-supervised learning has use cases in regression and classification. Self-supervised learning is like unsupervised learning because the system learns without using explicitly provided labels. It is different from unsupervised learning because we are not learning the inherent structure of data. Self-supervised learning, unlike unsupervised learning, is not centered around clustering and grouping, dimensionality reduction, recommendation engines, density estimation, or anomaly detection. Using self-supervised learning, machines can predict through natural evolution and consequences of its actions, similar to how newborns can learn incredible amounts of information in their first weeks, months of life by observing and being curious. Self-supervised learning has the potential to scale learning to levels required by new use cases, including but not limited to use cases in medicine, autonomous driving, robotics, language understanding, and image recognition. Self-supervised learning has found success in multiple fields, for example, in estimating relative scene depths without human supervision, by using motion segmentation techniques to determine relative depth from geometric constraints between the scene's motion field and camera motion. In medicine, it has found use cases robotic surgery and in dense depth estimation in monocular endoscopy. In autonomous driving, self-supervised learning is useful for estimating the roughness of the terrain when off-roading. In short, self-supervised learning brings us closer to human-like autonomous learning. Note that self-supervised learning is defined slightly differently depending on the context or area. All the examples and more information about self-supervised learning taught from Yann LeCun is linked in the description below. Please leave a like if you learned something and subscribe to the channel to not miss any terms clearly explained.